So here at the Ceph Days, we are not giving away any awards or something like that, but if you would give away an award for the longest travel, these two gentlemen would receive them. We now welcome a founder duo from the same time zone, but with the longest travel. After 12 hours flight all the way from Cape Town, South Africa, is a truly innovative solution. Please welcome Stuart, Managing Director with over 25 years in infrastructure development, and Zaid, CTO of Hexion. Their session, Ceph RADOS Gateway as an interface to the tape storage, presents a novel approach to long-term archiving. They use a small, high-performance Ceph cluster as a S3 interface to a tape library. Learn how the RADOS Gateway data pool becomes the intermediary between S3 and cost-effective tape storage, and how to efficiently manage massive long-term data growth. Welcome and goeiemorgen.
Thank you.
Thanks. As mentioned, my name's Stuart, and this is my colleague Zaid. We work for a company called Hexion Cloud Storage, which is situated in South Africa. We started building our first Ceph cluster only about 2 years ago, and what's unique about the cluster is that we developed it across 6 data centers, which are geo-redundant, and we run an 8+4 erasure coding scheme because we were trying to reach a certain fault tolerance. Because the network and the SAN spans over 40 kilometers, we had to do some interesting things, like we had to put down 15 dark fibers to run the lowest latency between our nodes, which today from node to node is about 0.3 milliseconds. And we run an all NVMe cluster. So today that allows us to provide high performance block storage using erasure coding and very high performance object storage to our customers in the region. We then decided to start thinking about building a cold storage tier that would be a lot more cost efficient, or an archiving tier, but we soon ran into a problem where we found that companies like AWS were selling their product for the same cost that we were building it. And what we didn't realize at the time is that these companies had found a way to interface object storage with a tape library. And it's at that time we started working with a really great engineering team and a company called Solo in South Africa, who had done some really great things in this space. So the central idea around their product and around what we did with them is to copy Ceph RADOS objects to and from a tape library. We love this idea because it allowed us to maintain our kind of open source nature and philosophy, and to stop us from getting locked into proprietary systems. To do that on the tape library side, they created a thin shim layer which sits in front of the tape library, which allows us to abstract the tape library functionality, so do things like move the arm and read barcodes. And in addition to that, we run a small high-performance cluster which handles S3 I/O and then does the storage of the data on a very durable and efficient storage environment, which is tape. So why would you do this? For us, it was simply about cost. How do we compete with AWS Glacier? How do we compete with IBM Deep Archive? And it was pretty simple. If we deployed $100,000 of CapEx, and we're going to talk only about CapEx right now, we knew that we could build a 2 petabyte HDD cluster, and that scales in a very linear manner. But when we looked at the tape library side, we firstly could get a lot more storage on an archiving basis for that minimum $100,000 spend, but it scales very well because once you've got the base library, the expansion frames are actually very cheap, and the cost just comes down over time. And if you then compare that to an LTO 10, so we're using LTO 9, that actually becomes even cheaper. So to look at a real-world deployment, there is a 64-dish array in the Karoo that currently helps us transform our understanding about the cosmos by taking high-resolution images of phenomena that emit radio waves. And those very, very large images have been historically stored on a HDD cluster running about 3,000 OSDs, which is about 50 petabytes in size. It's obviously been a great cluster, runs very well. We worked out just at a very, very high level that the cost to running that data is about $4 per month per terabyte, and the cost of powering that environment is about $17,000 a month. Today, alongside of that, is an 80 petabyte cluster tape library, which is what I referred to earlier. The massive difference in pricing once that's fully populated is it's around 65 cents, US cents per terabyte per month. And the use of electricity has reduced at a minimum of 75%, which from an operating cost point of view has made a big impact. That's what the actual environment looks like. So that is the base library with the 4 expansion slots. As I said, it's running LTO 9, so it's capable of 80 petabytes, but at LTO 10, that could be about 160 petabytes. So as technology evolves, it becomes a bit more interesting. And we don't have any of the engineers that run this product today here in Germany, but Zaid's going to talk a little bit about some of the technical details behind the solution.
Excellent. Thank you, Stuart. Good morning, everyone. Lovely to be in Berlin. Awesome city. So, yeah, as Stuart has mentioned, this is just a very high-level overview in terms of how our shim layer that our engineers have developed integrates seamlessly with the tape library. So, as you know, just a high-level overview, the S3 object uploaded into Ceph, split into multiple RADOS objects. The RADOS Gateway maps the head and the tail RADOS objects, which is then used by the shim layer to seamlessly integrate with any agnostic tape library. Locates the tail objects, stream it to tape, complete it, and once it's completed, the object on the Ceph cluster can be truncated or deleted even. When it actually also restores, the shim layer is responsible for integrating with the tape library, streaming the data back off the tape, reconstructing them into RADOS objects, and restoring it back to the customer. This is an overview of what it actually looks like once it's taken from the customer, deployed into Ceph, split up into a RADOS object, and eventually onto tape. Ultimately, this is a representation of what it would look like as it goes through its life cycle from the Ceph cluster onto tape, the data lifecycle in air-gap mode. After archiving, the RADOS tail objects can then be truncated or deleted. The metadata remains on the Ceph cluster, which is then accessed by Ceph itself. And yeah, that is basically it. As simple as that.
Thanks.
And one last slide. This is the management overview that our engineers have built and developed that actually monitors the live deployments. They are able to actually see the ingress and egress traffic. They were able to see the buckets that are backed up and so forth.
Yeah, so this actually manages or gives insight to a remote deployment in the Karoo, but it's managed from Cape Town offices. And that's it.
So thank you very much, Zaid, Stuart. Any questions from you regarding this?
So what would be the equivalent of scrubbing on tape?
Sorry?
Ceph does scrubbing, right, to make sure that the data is not lost or whatever. What do you do with tape?
Yeah, well, as Stuart mentioned, the engineers that has built the system are currently based in South Africa, Cape Town. But happy to take that offline. It's a good question.
Thanks.
Thanks. Is the interface to the tape open sourced or not?
It's not open source. It's proprietary software built by our engineers, our partner company, which is, Stuart has mentioned, Solo.
Okay, thanks.
What's the life cycle of a bucket in real terms? Like, you can store it on a tape, but if a user requests data, what's the impact or the latency, if you will?
Good question. It would be tricky to tell because when the data is requested by the customer or the user, it would go into a queue, which will then have to trigger the actual library to get the data. The user would get a message back to actually indicate that it's not stored in cache, that it needs to fetch it from the tape library. They should actually try again in an hour or two, maybe even a day, depending.
So no more questions. So thank you, Stuart. Thank you, Zaid,
Thank you,
for
Marcus.
this talk. Thanks.